conducts only when it's dissolved. Okay. Does it dissolve? Covalent bonding dissolves. Metallic does not dissolve. Okay. We could not dissolve aluminum. Does ionic bonding substances dissolve? Yes. Some covalent bonds do not dissolve, like network covalent. Example of substance of this type of bonding. So ionic, we talked about salt a lot. Covalent was sugar. And metallic bonding, we used the example of aluminum. Okay, draw the Lewis structure for the following. Let's start with CO2. So we have C and we have O. So we're going to count up our valence electrons. That's the first part. Carbon, there's one atom and it has 4 valence electrons, so we have 4. And oxygen, there's 2 of them in this formula, and oxygen has 6 valence electrons. So 6 times 2 is 12. So we have 16 electrons altogether. Right, now we need to place the central atom, in this case, carbon. And then we'll attach it to 2 oxygens, okay? So we have 2 electrons here, 2 electrons here. So we're down to 12, okay? Now I need to figure out where to put the rest of the electrons. Do I need more bonds? Do I need more electron pairs? What do I need? Well, if they all need 8, okay? Oxygen needs 8, carbon needs 8. This oxygen needs 8. So let's count them up and see if we have enough. If we have enough, we can put pairs, electron pairs. If not, we need to put a bond. So this oxygen is surrounded by 2 electrons. So it only needs 2 more. So it needs 6 more electrons. And this oxygen is the same, just needs 6 more. This carbon has 2 bonds. So 2 and 2, so it has 4, so it needs 4 more electrons, okay? 6 plus 4 plus 6 is 16, okay? That is greater than 12. Can you see that? Here, let me rewrite it here. 16 is greater than 12, okay? So that tells us we need bonds. And specifically, we can see 12, 13, 14, 15, 16. We have to count up 2 times. So we know we need 2 more bonds. So we'll put another bond here and another bond here. Okay, so that's 4 more electrons. So now we have 8 electrons. Okay, so now we can put the other 8 electrons here. Right, that got rid of our need for electrons here, that got rid of our need for electrons here, and that got rid of our need for some electrons here. So we only need 4 more electrons on each oxygen. And then we're good, okay? That's our drawing. Now, double check yourself. Always double check yourself and count up the electrons surrounding each atom and make sure it's 8. And then count up all of the electrons and make sure it adds up to whatever you got in the beginning. All right, let's repeat that with nitrogen and hydrogen, NH3. Nitrogen, there's 1 of them. Nitrogen has 5 valence electrons. Hydrogen has 1, but there's 3 of them. And then that gives us 5 and 3, so 8. So nitrogen will be the lone atom in the middle, and then the hydrogens will go on the outside, okay? Hydrogen only needs 2 electrons. So all of these hydrogens are happy, they're satisfied, and we just used up 6 electrons, so we only have 2 left, right? So we can put those 2 here, and then we have a 0, okay? That's the correct structure for nitrogen. Okay, this is a metal, and chloride is a nonmetal. So its ionic. So we need to draw differently. Okay, so we'll do magnesium, and it has 2 electrons, and then chloride. There's 2 chlorides, right? Magnesium is here, so it has 2 valence electrons. Chloride is here, it has 7. So 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, right? So this electron is going to join this chloride, and this electron is going to join this chloride. So what we end up with is a magnesium that has lost 2 electrons, so it has a 2+ charge. And then we have 2 chlorides that have gained 2 electrons, so they have a 2- charge. And then we'll draw all of the electrons around them. And that's your answer. There. Okay, one more page. So the question here is there a pattern? And yes, there is a pattern. There is a pattern. This one, there's no pattern. This one, there's one outlier. Okay, it's going up, 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 except for these 2 cases. So there's 2 outliers. So it's not consistent. 2 is a little bit too much. It's not really consistent. Okay. Atomic radius. Draw arrows showing the trend of increasing size. Increasing size is as you go down and to the right. So, which is larger? Circle the correct answer. Lithium or beryllium? Lithium's here, beryllium's here. Okay, so lithium is more to the left. It'll be larger. Sodium or potassium? Sodium's here, potassium's here. As you go down, atoms get larger, so it's going to be potassium. Silicon or phosphorus? Silicon is here, phosphorus is here. Silicon is more to the left. It's going to be larger. Fluoride or chloride? Chloride is lower. It's going to be larger. Cobalt or nickel? Cobalt is here, nickel is here. Cobalt is going to be larger. Titanium or zirconium? We don't talk about this too much. Okay, here's titanium, here's zirconium. Zirconium is further down, so it's going to be larger. What property of atoms changes going left to right across periodic table that causes atoms to get smaller? It's a greater number of protons, right? Which have a positive charge, so they attract electrons. Okay. Okay, here, I'll just write it up here. Protons attract electrons. Okay. What about this part? What property of atoms changes going down a group causing atoms to get larger? More electron shells. Okay, so what do I mean by more electron shells? You have the nucleus, and you have another electron shell, another electron shell. Here's an electron, here's an electron. They're repelling each other, okay? And that causes the atom to get larger and the electrons to get further away. What is the most electronegative element on the periodic table? It's fluorine. Mr. Dilla, how do you know that without even thinking about it? Okay, for the same reason, okay, electronegative means attracts electrons. So what attracts electrons? Anything with more protons and less shells. Okay, so what has less shells? Stuff that's up high. What has more protons? Stuff that's over to the right. Okay, so that tells us that fluorine is going to be the strong. It would be helium, but the noble gases are already stable, so they don't attract electrons. Because that's the other part, is that they have to have 8 electrons in their outer shell. All right, scholars, I hope this is hopeful. Good luck on the midterm tomorrow. I believe in you, and good luck.